In this video, we're going to talk about a very important concept in mathematics, namely the absolute value of a real number. And we're going to introduce this concept by considering a very natural question. And that question is, if x is an arbitrary real number, then how can we describe the distance between the number x and the real number 0 on the number line? Let's consider a simple example. If our real number x is equal to 5, then we can see very clearly how the numbers 5 and 0 are positioned relative to one another on the real line. And it's quite clear that the distance between 0 and 5 is simply equal to 5 itself. And that's basically true because 5 is a positive number, or in other words, because 5 lies to the right of 0 on the number line. On the other hand, if x is equal to a negative number, like -5, then it's no longer true, of course, that the distance between x and 0 will just be x itself. On the contrary, the distance between -5 and 0 is also just equal to 5. These examples go to show that the distance between x and 0 is not always equal to x itself. Rather, it will depend on whether x is positive or negative. In any case, we can go ahead and set it as a definition that the absolute value of a real number x is equal to the distance between x and 0, and the notation that we use to describe this is absolute value notation, which involves placing so-called absolute value brackets, which are basically vertical bars to the left and to the right of the number x. To be more formal, and to build upon the example that we looked at before, we would say that the absolute value of x is, by definition, equal to x if x is greater than or equal to 0, or if x is negative, the absolute value will be equal to -x. And the reason for this is very straightforward. If x is a negative number, then its distance from 0 needs to be positive, and to make a negative number positive, you simply put a minus sign in front of it. By the way, this bit of notation, which might look a little scary at first glance, is an example of what mathematicians call a piecewise function. And you'll see this notation crop up more frequently the more you continue on your mathematical studies. It gets its name from the fact that we're defining something in different ways on different pieces of the real number line. In this case, the piece of the real number line where x is greater than or equal to 0, and the piece of the number line where x is less than 0. Let's now turn to a related question. We know that the absolute value of x describes the distance between x and 0, but what if we'd like to consider a more general situation? Namely, what if we'd like to consider the distance between two arbitrary real numbers, x and y? So this time we're marking two totally arbitrary numbers, x and y, on the number line and trying to figure out the distance between them, or the distance indicated by this horizontal bar. Now, it's quite clear that if x is greater than y, or in other words, if x is to the right of y, as is the case in our picture, then the distance we're interested in is just going to be the bigger number minus the smaller number, x minus y. But be careful, because what if things are reversed? What if y is greater than x? Well, then the distance would be exactly the other way around. It would be y minus x. And we need to be careful to take these two different possibilities into account. Indeed, if x and y are completely arbitrary and we don't even happen to know which of them is greater than the other, then the thing to do is to simply take their difference, to subtract one from the other in any order, but then take the absolute value of that difference, since we want it to be non-negative. And this leads us to the following important fact, which will appear in mathematics again and again, namely that the distance between two arbitrary numbers, x and y, is equal to the absolute value of the difference of x and y. Let's finish off by considering a few examples that will get a little trickier as we go down the list. To begin with, let's think about how to compute the absolute value of 8 minus 15, or in other words, the distance between 8 and 15. Here, we're able to move step by step by simply first computing 8 minus 15, that's equal to negative 7, and then by taking note of the fact that the absolute value of negative 7 is, of course, positive 7. In our second example, we're being asked to think about the absolute value of pi minus 3. And here we should remember the approximate value of pi. Pi is roughly 3.14. It's a bit bigger than 3. And so it follows that pi minus 3 is a positive number. Well, as long as pi minus 3 is positive, the absolute value of pi minus 3 will, by definition, just equal pi minus 3 itself. So here we're allowed to remove the absolute value brackets, since what's in between them is already positive. On the other hand, let's take a look at our third example. When we think about the absolute value of pi minus 4, we have to be sensitive to the fact that pi is less than 4, and therefore that pi minus 4 is a negative number. Well, to take the absolute value of a negative number, what we want to do, by definition, is multiply that negative number by negative 1, just like this, to make it positive. And after distributing the minus sign, we see that this is simply equal to 4 minus pi. So we may rewrite the absolute value of pi minus 4 as 4 minus pi, which is a positive number. And finally, this last example is particularly important. To take the square root of x squared, here we're going to combine radical notation and absolute value notation in one exercise. We have to be careful about what the radical notation represents. Recall that it means to take the positive square root. It is tempting to rewrite the square root of x squared as x, but this isn't always correct. Because just imagine that x is equal to a negative number. Then we would have a contradiction on our hands, right? We can't take the positive square root of x squared and get something x that's equal to a negative number. The correct way to rewrite the square root of x squared is as the absolute value of x, because once again, we need to make sure that as long as we're taking a positive square root, our answer is indeed a positive or non-negative number.